Hey everyone, and welcome to our vocabulary day where we are going to describe polynomials. We are going to be using these words a lot, so it's really important that you guys understand exactly what they mean, because if I say a cubic binomial and you have no idea what I'm talking about, it's going to be really difficult for you to follow along. So let's go ahead and just jump right in. We've been talking about equations for goodness, probably since middle school, but just to give you a refresher, an equation is going to be an expression, and don't worry, we're going to define expression in the next one, an expression with an equal sign. So an equation is always going to have the equal sign. Alrighty. Now, an expression is going to be a combination of terms and if you're not quite sure what a term is, don't worry, we're going to define that here. Combination of terms with no equal sign. So if you see something that has an equal sign, that's going to be your equation. If you see something without an equal sign, that's an expression. That is the main difference between the two. Now, an exponent is a base raised to a power. And let me give you a quick example of that. So an example, EX's example, would be x squared, where x is your base and the tiny 2 is your exponent. Okay? So the larger letter is your base, and the tiny number is your exponent. Alright, so now we're going to talk about term. A term is going to be a number, or a variable, or a number and a variable, multiplied together. So let me give you some examples of terms. So a term could be a number, so we'll just say 3. It could be a variable, everybody's favorite variable is x, or it could be a number and a variable multiplied. So that could be 2x. Okay? Now, it can also be an exponent, so a number with an exponent, so then it could be 4x squared. Okay? And I say squared to mean the tiny 2, and you will hear that a lot. Alrighty. Now, a constant is going to be a number with no variable. So some examples of that be like 1, 5, 8, 100. They are just numbers. Also, just to make sure you guys understand what I'm doing, these little dashes are commas. Just making sure. Alrighty. Now, a coefficient, that is the number in front of the variable. So if we have, let me give an example. If we have 3x, then 3 is your coefficient. Okay? Now, there is also a tricky one where if you just have x, then there is actually a secret 1 in front of your x, and so your coefficient would be 1. Okay? Alrighty. Leading coefficient. So when your polynomial is in standard form, and don't worry, we're going to talk about standard form right here. The leading coefficient is the first coefficient. Okay? Whoops, when your polynomial is in standard form. I knew I was forgetting something. So when your polynomial is in standard form, it is the first coefficient. Sorry about that. All right. And then degree is going to be the highest or largest variable exponent. So remember we said that an exponent was a base raised to a power, and the exponent was the tiny number, okay? So when we are asking about degree, we're asking about the largest tiny number. Okay. And now standard form. Standard form is a simplified polynomial and its terms are written in descending order by the exponent. And remember that descending order is going to be largest to smallest. Okay? Alrighty. So we've gotten through all of that vocab. If you need a moment, take a minute, pause the video, and reread over all of this vocabulary, and then we will finally discuss what a polynomial is. Okay? Alrighty, so hopefully you paused your video and took a minute, because now we're going to talk about polynomials. Polynomials are a single term or a sum/difference of terms. Okay? They have variables raised to whole number exponents that are greater or equal to 0. Remember, that's what this sign means, greater or equal to 0. The variable, remember the letter, cannot be raised to a negative exponent. So it cannot be raised to a negative exponent. It cannot be under a radical. And it also cannot be in the denominator of a fraction. Okay. So that's a lot. So polynomial can be a single term. Remember, a term is a number, a variable, or a number and variable multiplied together. Or it can be the sum and difference of terms. And they will have they can have variables raised to whole number exponents greater than 0. and that variable, like the x, cannot be raised to a negative exponent, it cannot be under a radical, and it cannot be in the denominator. Okay? So, let's do some examples. So we talked about a polynomial can be a single term. Well, a single term can be 3. That's a single term. It could also be x. It could also be 2x. It could also be 4x squared. Wow, these examples look really familiar. I wonder where I got them from. I got them from our term examples. Okay? Because a polynomial can be a single term. Okay? But it can also be the sum or difference of terms. So let's take a look at that real quick. So the sum and difference of terms. So that means that it could be 3 plus x, because that's a sum. It could be, now that one is not in standard form, but we'll get to that in a minute. It could be 2x minus 3, because sum or difference. It could be 4x squared plus 2x minus 3. Okay, all of those are examples of a polynomial. Okay, and this last one is in standard form, but we'll talk about standard form more in a little bit. Now some non-examples. In our definition, it tells you what our non-examples are. The variable, the letter, cannot be raised to a negative exponent. So if we're looking at x, and it cannot be raised to a negative exponent, then a non-example, something that is not a polynomial, then this cannot be raised to a negative number, like -1. So that is not a polynomial. Okay? Neither is 4x to the -6th power. Okay, that is a non-example. All right. What about under a radical? Radical is another word for square root. Okay, or at least in algebra it is. Alrighty. So if it can't be under a radical, remember radical looks like that, then that's a non-example. Okay. Something else that is not an example would be, let's do 3x to the 5th. That is not a polynomial. And then our final example is that our variable cannot be in the denominator. So if it can't be in the denominator, that means that it cannot be on the bottom part of our fraction. So we cannot have 3 over x. That is not a polynomial. Okay? So those are your examples for polynomials, and I'll draw this line out a little bit more. There you go. So we have our examples of polynomials and things that are not polynomials. Okay? Alrighty. So now let's move on to some more vocab. Yay, everybody loves vocab. And this vocab is going to be used to describe our polynomials. Okay? So the first way that we can describe a polynomial is by degree. And remember, if you look on your previous page, the degree was the highest or largest variable exponent. Alrighty? So if your largest degree is 0, then that is going to be called a constant. Okay? And a constant, if you remember, is a number with no variable. So an example of a constant would be 2. It could also be 48. It could be 153. Okay? Those are just going to be examples of constants. So any number that does not have a letter attached. Okay? So when it has a degree of 0, constant, and it looks like one of these numbers. Linear is when you have a degree of 1. So when you have a degree of 1, it's linear. Okay? This could be something like our 2x. Now you might be saying, but Miss Johnson, 2x, if we are classifying by degree, which is our largest exponent, and an exponent is the tiny number, where is the tiny number? Remember over here, we have our base and our exponent. It's the tiny number. Well, there is actually a secret tiny number here. Whenever you have an x, that means that you have 1x. Okay? So it has a tiny number of 1. Alrighty? So when it's linear, you will have an x. Alright, let's look at another example. Another one could be, let's see. Let's do this. It could be 3x minus 2. Because remember, we are classifying it by the degree, the highest exponent. So it doesn't matter that we also have a constant in here. We are classifying it by the largest degree, by the largest exponent, okay? All right. So now, let's take a look at when our largest degree is 2. This is going to be called a quadratic. Quadratic. Okay? So an example of this is when you have x squared. That's when your exponent, your tiny number, is 2. Okay? And so another example of this could be 6x squared minus 3x plus 2. Okay, so now we're adding on, but our largest exponent is 2, because this is 2, this is 1, and this is going to be 0 because you don't have an x. Alright, let's take a look at cubic. This is when you have a degree of 3. So hopefully you can guess what I'm about to do next. I'm about to have an x with a tiny number of 3. Okay? And then our example can be 4x cubed minus 5x plus 1. Miss Johnson, you changed it up on us. This time you didn't include all of the terms. That's okay. You don't have to have the 3, the 2, the 1, and the 0. You can have any combination, but so long as the 3 is your largest exponent, then it's still going to be a cubic. Okay? So remember, we're just talking about the 3. Okay? Alright. And then 4th degree. So later on in math classes, you might actually get the names for these, but in algebra class, when you have a degree of 4, it's just going to be called a 4th degree polynomial or a 5th degree polynomial. Okay, but let's focus on 4th degree. So hopefully by now you know exactly what I'm going to do. And then for our example, I'm going to have x to the 4th plus 2x cubed plus 4x squared plus x. Okay, and this time I don't have a constant term. Okay? but it is still going to be a fourth degree polynomial because my largest exponent is 4. And then the last one for a degree is our fifth degree, and hopefully you've got the hang of it by now. So you can create your own example. I'm just going to do a little bit shorter one. We'll do 2x to the fifth plus 1. Okay. Cool. So that is our fifth degree. We have done constant, which is a 0 degree, which means that there is no variable, there's no x. When it's linear, you will have an x there. Okay. When it's quadratic, you'll have the x squared. When it's cubic, x to the third, or x cubed. You can think of this one like 3D cube. When it's fourth degree, you'll have a 4, and when it's fifth degree, you'll have a 5. And remember that these must be the largest in order for you to classify it by degree. Okay? Alrighty. So now we're going to classify by type. Okay? By type. And type is the number of terms. So if you recall, the term is the number or variable or number and variable multiplied. Okay? So the first one is going to be a monomial. This is only going to be one term. So a monomial can be x. Okay? That is one term. Or, and I'm going to make a little bit of space here so that you see, or it can be a number, like 4. Okay? So those are monomials. That only has a single term. Okay, a binomial is going to have 2 terms. Now, when you have more than one term, each term is going to be separated by a plus or a minus sign. Okay? So a binomial can be 2x plus 1. So you have one term here, and the other term is here. And that is a binomial. Okay? Now a trinomial will have 3 terms. Okay? So let's do 4x cubed plus, let's do 3x plus 5. Okay? This one has 3 terms because it has 1, 2, 3 terms. And that's a trinomial. Alrighty. Now let's take a look at fourth term polynomial. Okay, so this is going to have 4 terms. So this can be 4x cubed plus 2x squared plus 3x plus 6. Alrighty. So then you have 1, 2, 3, and 4 terms. Okay? Doing all right? Okay. And then we're going to do fifth term polynomial. So this is going to have 5 terms. So I'm going to do x to the 5th minus, let's see, 2x cubed plus 5x squared plus x plus 7. Oops. There we go. And so then we have one term, 2, 3, 4, and 5 terms. Okay, so hopefully now you can see that each term is separated by the plus and minuses. I used a lot of pluses here, but minuses also work. Okay? Alrighty, so the next part requires a little bit of critical thinking. Okay, oh my gosh, we actually have to use our brains. Okay, so we need to complete our following statements with always, sometimes, or never. And this is just really going to help you think about polynomials, their degrees, and their terms. Okay? A linear function is blank a trinomial. So, is a linear function always a trinomial? Well, think about what a linear function is. What did we say it was? Linear function is when the highest exponent is a 1. Okay? So, look at our example and then define a trinomial. Trinomial has 3 terms, 1, 2, 3. But if we look at our example for linear, I have one that has 1 term. I also have one that has 2 terms. Okay, so it's definitely not always a trinomial. So then let's look at sometimes a trinomial. Could a linear function be a trinomial? Well, let's take a look at our example again. I have 3x minus 2. This is not a trinomial because it only has 2 terms. Could we add another term to it to make it a trinomial? Well, if we want to add, let's put it over here. Okay, so this is going to be our example for number 1. Alright, so if we want to add a term, okay, I think the first thing that you guys would think of is to add another constant, another number. But unfortunately, this doesn't work because you can combine these terms. What is negative 2 plus 4? It's going to be 2. So we're left up with 3x plus 2, which is still a binomial. Okay, so that didn't work. What if we added just another term to it? Like what if we did x squared plus 3x plus 2? Well, that doesn't work because now our largest degree, our largest exponent is a 2, which makes it quadratic. So that doesn't work. So a linear function can never be a trinomial. Okay, you can think of it like this. 1, 2. Okay, this is how many, this is the maximum amount of terms you can have in a linear. 1, 2. Okay? Alright. Now let's take a look at the next one. A cubic function is blank a binomial. Okay? A cubic function has a largest degree of 3, and a binomial has 2 terms. Alright, so let's use that trick that I just showed you. Okay? So this trick shows you the largest amount that you can have, the largest number of terms you can have based on your degree. So 1, 2, 3, 4. Okay? And you can see that, show you another example down here, because we can have x cubed plus x squared plus x plus 1. Okay, this is the most basic 4th term cubic. So 1, 2, 3, 4 terms. Okay, so it's definitely not always a binomial because that would mean that it always has to have 2 terms. Okay? But it's also, you could also have 2 terms, just like that. Okay? Let's make sure. There we go. So you can still have your two terms, so it's not never a binomial. So for number 2, we can say that it is sometimes. I know, guys, this is a lot of thinking. Okay? I get it. Alright. Now take a look at the next one. Hopefully number 3 is going to be a little bit easier. Okay? A constant function. Remember, a constant is just a number. 2, 48, 153. Is blank a monomial? Well, a monomial is a single term. Okay? So this time, if we look at our examples, and there's nothing above it, it's just the 1, this one is always going to be a monomial. Okay? And hopefully the next one will also be a little bit easier for you guys. A degree 3 polynomial. Okay, so we're going to go to degree and 3. Okay, so that's our cubic. Is blank a cubic function? Well, we just said it was a cubic function, so this is going to be always. Doing all right? Okay. And then the next one, the degree of a polynomial is blank negative. The degree, okay, so this is going to be that tiny number. Well, if we go back over to our definition, it says the variable cannot be raised to a negative exponent. So our degree cannot be negative. So the degree of a polynomial is never negative. Alrighty. And then the leading coefficient of a polynomial is blank positive. So if you recall from our earlier definitions, our leading coefficient is the first coefficient when we're in standard form. Okay? So if I have, I'm going to do an example over here. If I have, let's do 2x squared plus x plus 3. This is going to be in standard form because it is simplified and our exponents are in order from largest to smallest. Okay? And this time our leading coefficient is the very first number and it's positive. If there is not a sign in front of it, you can assume that it's positive. Now, you can also have a negative as your leading coefficient. Negative 3 would be our leading coefficient. Okay? So our leading coefficient is going to sometimes be positive. Okay? Alrighty, we've done a lot so far. Okay, so how about we stop the video here, we'll take a break, and then we'll come back to finish up our notes.